Okay, we're going to start this lesson by covering what polynomial functions in one variable means. We've got some really ugly stuff written on the screen, so we'll go through this kind of slowly and make sure we understand it. General form of a polynomial function in one variable means we've got only one variable. It kind of looks like we've got multiple variables up here with the a and the x and the n, but x is actually our only one variable up here. The rest stand for constants that we would be filling in for. So here we have our x to some degree, the nth degree. And if you notice, it's just going to subtract 1 each time, and minus 1 and minus 2. So this could be like x to the third power plus 2, x to the second power plus 3, x to the first power minus 7, x to the 0 power. And it keeps walking its way down until we're out of x's. Well, we know that x to the 0 power is 1, so that's actually just minus 7. And x to the first power is actually just x. So here we have a polynomial that I've filled in here of degree 3, where my a sub 0 would be equal to 1, my a sub 1 would be equal to 2, my a sub 2 is equal to 3, and then my a sub 3, which is actually my a sub n in this case, is a negative 7. Again, this will make more sense as we go along and kind of talk about this some more. So note that form right there, the a sub naught, 0 meaning naught, times x to the nth power plus a sub 1, x to the n minus 1, is just a general form of this arrow. It just means we have a whole bunch of different leading coefficients, where these a subs are your leading coefficients, and we walk our exponent down by 1 each term. So if we look down below at my two examples down below, we want to find the degree of a polynomial in one variable, which means we want to find its greatest exponent. We first look, make sure we only have one variable going on here. And this expression, we only have an x. And the largest exponent on that would be 4. So this degree would be degree 4. And one below it, look at it and you go, oh, we're at degree 1 because that's our leading coefficient. But in this case, our leading coefficient is the degree, or the term with the highest degree. So if we were this, that would become 4x to the 4th plus 8x to the 3rd minus 9x squared plus 7x 5. You can take the leading coefficient. There's our leading term. Our leading coefficient would be the 4. And our degree in this one would also be the 4. This one is degree 4 with leading coefficient of 4. And the one above it was degree 4 with leading coefficient of 5. The first term with the highest exponent is a 5. So on these examples down below, we wanted to state the degree and leading coefficient of each polynomial in one variable. It's not okay, breaking these down, we'll go through first one. First of all, we need to make sure we have one variable. So we look at this first expression. Have a z. Z is the only variable in each one of them, so it is in one variable. And then we want to state the degree, so we want to look for the term with the largest exponent, which happens to be in order. And so the degree on this one would be degree 3, and the leading coefficient on this would be 7. Because 7 is the coefficient, with the largest exponent being the 3. Looking to the next one down, what to look for is one variable. We've got an A, we've got an A, we've got an A, we have a B. So not one variable. polynomial in one variable because it uses two variables, an a and a b. Let's look at the next one. First, does it have a variable? And that would be a yes. It's got C, C, and C. Next thing, something we haven't really talked about, but I need to get here, is that we can't have 1 over C. 1 over C would be putting it in the denominator, and that would not be multiplying by it, would be dividing by it, and it makes a huge change in our function. And so we look at this and we go C squared, C to the first, C to the negative first. And C to the negative first, if you guys remember, is the same thing as 1 over C. So 1 over C is a polynomial in one variable. It's not considered to be that anymore because we have C to the negative. Let's go down to the third one. Let's get a fourth example. Move that on up. So our first step is to see, do we have everything the same? We've got a y squared, and a y to the fourth. So yes, they're all one variable. We have no negative exponents. So everything is in the numerators, and we have no variables in our denominators. And the third thing is we want to put it in order. So in this case, we would have y to the fourth minus 3y to the second plus 9y. Then you want to find your leading term. Our leading term is our term with our greatest exponent. From there, we can find our degree. And the degree in this case would be a 4 because the exponent is a 4. And our leading coefficient is a 1 because it's always assumed to be a 1y to the fourth. And so that would finish our examples.